All right, class. Welcome to part two of the 1.2D lesson video. Uh, out of all the videos that I've made, I really emphasize watching these videos because a lot of students usually say that word problems are the most difficult for them. So my hope is that if I provide a lot of detail in these videos, it will serve as a great resource for you so that you can kind of go back to this video and refer to this video if a homework question is challenging for you or something like that, right? So let's look at number 5. This is on page 54 of the module, and this is again the 1.2D lesson. It says the length of a rectangle is 4 more than twice its width, right? So we're realizing that the width is going to be the second noun, right? The length is compared to the width. If the perimeter of the rectangle is 98 inches, what is the area of the rectangle, right? It's not asking for the length and the width this time. It's asking for the area. So let's do a quick recap. We know that the perimeter is really just L plus W plus W, right? Here's a visual in case you've forgotten. A rectangle looks like this. There's 2 L's and 2 W's, right? Now, some people like to make this even simpler and just say that it's 2 times L plus W. If you just take your L plus W and add those two values up, you can then double it and you'd get the perimeter. Okay, so just that's something we need to know before we even start, and hopefully it's obvious. Another one that we need to review is the area. The area is literally the two-dimensional shaded region of the rectangle, which would be the product of length times W in this case, right? The area of any rectangle is always its length times its W. Totally different than perimeter. Perimeter is the outer edge. Area is the inner shaded portion of the edge. Okay, so now let's go ahead and read what it says. It says the length of a rectangle is 4 more than twice its width. So I'm going to start by saying that the width is going to be x, right? We know that the width is the noun after the comparison. The width is x, and the length in this case is going to be 4 more than twice. Okay, so I was able to do that rather quickly. I actually hope that some of us are so comfortable with these word problems that this came pretty easily for you as well. But now we're going to go ahead and, we could add these up and then double it, and that would give us the perimeter, which in this context is 98. Okay, so that's what I'm going to do. I'm going to go ahead and double it. 2 times x plus 2x, which is 3x plus 4, and that's going to equal 98, right? That's the total perimeter. Now, instead of distributing the 2, I'm going to go ahead and just divide it by 2, and I get 3x plus 4, right? Half the perimeter should equal half of 98, which is 49. And you then end up getting 3x is equal to 45. Okay, moving kind of fast, but the calculation part should be the easiest, right? X is equal to 15. So I now have x is 15. Let's just double check. If x is 15, the length would be 34, right? A lot of layers in this one. And let's just really see it. Let's see if that's true. And 15. Maybe this picture is even drawn to scale. Like, Mr. Quill, your skills are so strong. Your picture is drawn to scale and it looks pretty accurate. Let's see. Like 15 plus 15 is 30. 34 plus 34 is 68. And you can see that does add up to 98. Okay. Wow. Okay. But still, that's not the final answer, right? The final answer says, what is the area of the rectangle? By the way, these are all in inches. It would be nice if we provided the units. The area is simply going to be 15 times 34. The first person that announces what this 15 times 34 is wins. What is 15 times 34? Well, I know that that's going to be 340, right? 15 times 10 plus 170, isn't it? Because 34 times 5 is 170, and this gives us a grand total of 510, and you want to label it inches squared. And then you have to write your answer in a complete sentence. So I'm going to say the rectangle has dimensions of 15 by 34 for an area of 510 inches squared. And that's like the perfect, best possible answer you could provide. I really like this question. I think it definitely challenges you to first obviously know what perimeter is, area is, and then you have to follow what the context says and then translate what it says, solve for each dimension, and then finally answer the area. We're moving pretty fast. Like we're kind of now we're expecting you to be very comfortable with these word problems. Okay? All right, let's try one more. So it says number 8 says Jackson is 8 years older than Sam. Whoa, let's just stop right there, right? Jackson is 8 years older than Sam. Then, circle then, pointed at the noun after the comparison, right? Immediately, Sam's current age, I'm going to call it X. Right, Sam's current age is X. Jackson's current age is 8 years older. So let's say X plus 8. And that should make sense to you, right? Especially for those that have siblings and whatnot. Like, you should realize you can compare two people and their ages. Jackson is 8 years older than Sam, right? Now, 3 years ago, Jackson was twice as old as Sam was then. So maybe this goes without saying, but do we realize that 3 years ago, Sam's age 3 years ago was a simple X minus 3, right? And then obviously Jackson's age 3 years ago, Jackson's age 3 years ago, it's whatever he is now minus 3, right? Okay, but it also says that Jackson was twice as old as Sam. So I'm going to give you a visual of what that means. That means 3 years ago, whatever Jackson was, like let's call this Jackson, right? He was twice as old as Sam. And this is just a vertical visual. So think about this, class. If you're creating an equation, who should you double to set the two nouns in this case, the two individuals? Who do you have to double for them to be equal? Would you double Jackson or would you double Sam? So I hope this visual tells you that you have to double Sam, right, in order to set them equal to each other, right? It says 3 years ago, Jackson was twice as old as Sam. So in order to set them equal to each other, Sam needs to be doubled, right? Sam needs to be doubled. So let's do that. Okay, Sam needs to be doubled. So Jackson, x plus 8 minus 3. I'm going to go ahead and do x plus 5. 3 years ago, that's what Jackson was. And then I'm going to double Sam. Because if I don't double Sam, I can't set them equal to each other, right? If you don't double Sam, you will not have an equation. So if you double Jackson, that's like saying Jackson is 2 years older, and I'm going to double Jackson to make him like 4 years older, or 4 times older, I should say. That doesn't make sense. You have to double the one that needs, the one that's literally half, right? You can't double the one that's already twice. Okay, I hope that made sense. And obviously, when you check your answers have to line up as well. But the solving portion is, again, the easiest portion. I kind of went a different route, kind of an interesting route, and I got negative x is equal to negative 11. But obviously, that just means that x is 11. And that means x is the current age of Sam. Right? If x is 11, that's Sam's current age. So then I know that Jackson right now is 19, right? X plus 8 is 19. And you would say Jackson is currently 19 years old. And let's just really think about it. 3 years ago, Jackson would have been 16, and Sam would have been 11 minus 3, which is 8. So Jackson would have been twice as old as Sam 3 years ago. Okay, I think the key to these questions, class, is you definitely want to make sure you label current age and previous age or past age. Like this box that we made over here is really, really important. I think sometimes if you don't label current and stuff like that, a lot of students tend to make a mistake on this one because they forget to realize, is that the current age or is that back then 3 years ago and all that? So please make sure that you label current and 3 years ago, as I have here. Okay. If you have any questions, please, do not hesitate to contact me and let me know, and maybe I can provide more information. Okay. Thanks for watching.